So in today's lesson, we're going to learn how to write equations, but specifically only given a point and a slope. And once we give the point and the slope, we're actually going to be able to write the equations in three different forms. So let's go ahead and get started with this review question. Suppose you want to start a lawn mowing business. So you go out and you buy a mower for $360 at the beginning of the summer, and then you start charging people $30 to mow their yard. And so we're going to want to write an equation for this. From this information, there's two pieces of information that they gave us. One is the slope, which is $30 per lawn. That's the change. Remember, the slope is how something changes. And so every lawn that you mow, you get an extra $30. The y-intercept is where you start at. So because you bought the mower for $360, you started down $360. And so if we were to write an equation for this, it would be y equals 30x minus 360. 30x because that's the slope, and we know that the slope is going to be y equals mx plus b. So the slope is times the x, and then minus 360 because you started the beginning of the summer being $360 in the hole. So if we want to answer these questions based on our equation, how much money will you have after mowing 10 yards? Well, you would just stick 10 in for x. You would take 30 times 10 minus 360. And 30 times 10 is 300. 300 minus 360 is negative 60. So after mowing 10 lawns, you're going to be negative $60 still in the hole. After mowing 20 yards, though, you would plug a 20 in for x. And it's going to be 30 times 20, which is 600. And 600 minus 360 is 240. And so we would have $240 after we mowed $20. Plus we would have our lawnmower. So that's an equation for your lawn mowing business. Suppose, though, that you have a friend that also started a lawn mowing business, but all you know is that instead of charging $30 per lawn, they only charge $25 per lawn. That is their slope, $25 per lawn. You also know that after 11 lawns, they have a total of $40. So you don't know how much their lawnmower cost, but you do know this particular point, that after 11 lawns, they had $40. Well, this is a point and a slope. Can we come up with an equation just like the one we came up with for our own business that is in slope-intercept form? So we're going to do this using two different methods. The first method is to use slope-intercept form. Then we're going to use another form called the point-slope form in order to do the same thing that might be a little bit easier than using slope-intercept form. So let's first do it with slope-intercept form. We know that slope-intercept form is y equals mx plus b. And I know that the slope is 25, so I'll have y equals 25x plus b. If I knew what b was, I could just write it in there and have my equation. But I don't know what b is. What I do know is this. I know that x is the 11 is an x and the y is a 40 at the same time. So if I plug 11 and 40 in for x and y at the same time, I'll get a true equation, a true sentence. And so then I could use that information to figure out what b is. Let me show you what I mean. If y is 40, when x is 11, I'm going to plug those two numbers in. I'm going to plug 40 in for y, and I'm going to plug 11 in for x plus b. Everything else stays the same. Now I can figure out what b is, because I know that 25 times 11 is 275 plus b. And if I subtract 275 from both sides, this will be gone. But if I subtract it from this side, I'll have negative 235 is what b is. That's a b. So b is negative 235, and my equation would look like this. Y equals my slope, which was 25x. That hasn't changed. But now I know my y-intercept is negative 235, which means my friend must have bought a lawnmower for $235. Doing it this way is not a bad way, but let's try it with a different form that we're going to develop in the next slide. The other form is called the point-slope form, and it looks like this. It's y minus y1 equals m times x minus x1. This is going to be a formula that you will have memorized here. But let me show you how it works. We're going to have y minus our y value. So in the point that we have, our y value is 40. That equals the slope, and we know that the slope is 25. And it's going to be x times, or x minus the x value, which is 11. So I'm just going to plug my x and y in for x1 and y1, and plug my slope in for m. And now I'm going to write it in this form. I want to get the y by itself. But before I can get rid of this 40, I'm going to get rid of these parentheses here. So I'm going to distribute my 25. It's going to be y minus 40 equals 25x. 25 times negative 11 is negative 235. Then if I add 40 to both sides, I am going to have y equals 25x, but negative 2, this is 275, not 235. Negative 275 plus 40, there's my negative 235. And so that's how I can use the point-slope formula to get the same equation in slope-intercept form. And I don't know if you thought that was easier, but I would like for us to work with the point-slope form here for a little bit, because it's a really nice way to write equations when we're given a point and a slope. How did that formula come about? Well, let's just go through this. You remember this formula for slope, y2 minus y1 equals x2 minus x1? If I put parentheses around the top and the bottom, it'll look like that. But let's suppose I want to get rid of this fraction. I would multiply it by the common denominator, which is x2 minus x sub 1. And if I multiply both sides by that, this is what I will get. Over here, I'll have m times x2 minus x sub 1. And over here, these will cancel each other out. So I'll get y2 minus y1. And then by rearranging that formula around a little bit, if I put this over here on this side, this over here on this side, then I get this formula, which is the point-slope formula. Y minus y1 equals m times x minus x1. Let me show you how this works with a different example. Suppose a worker at Wendy's gets paid $8 per hour. Well, that's our slope. Gets paid $8 per hour. We know that's the rate of change. And we know that after working 12 hours, she brought home $66. Well, you know that 8 times 12 is not 66. And so she must have started out in the hole. She must have had to bought maybe she bought her t-shirt or her hat in order to work there. And so that would be a cost for her. And so we know that the slope here is 8. We know that we have a point which is at where x is 12 and y is 66. And so how can we use the point-slope formula to write an equation for this situation? And we know that the point-slope formula is y minus y1. That equals m times x minus x1. And if I plug in my y value, y minus my y value, that's y minus 66, equals the slope, which is 8, times x minus my x value, which is 12. And so then I just want to put it in slope-intercept form. So I want to get the y by itself, but I'm first going to distribute this 8. It's going to be y minus 66 equals 8x minus 8 times 12 is 96. And then if I just add 66 to both sides, then I'm going to have y equals 8x minus 30. And so her hat and shirt must have cost her $30 because she started out $30 in the hole. And she gets $8 an hour. So now we could use this formula to figure out how much she gets paid. Let's say she worked for 20 hours. Well, we would just stick 20 in for x. 8 times 20 would be 160. 160 minus 30 would be $130. And so here is our formula that we would use. Well, what I'd like for you to do is to pause the video at this point and try to work through these next two problems before you start the video to make sure that you've done it correctly. So hopefully you've done that, and what I'm going to do first is write an equation of a line that goes through this point that has a slope of -2. So I'm going to start with the point-slope formula, which is y minus y1 equals m times x minus x1. So that's going to be y minus my y value, which is 1. That equals the slope, which is -2, times x minus my x value, which is 3. Then I'm going to use the distributive property. I'll have y minus 1 equals -2x plus 6 because it's a negative 2 times a negative 3. Then I'm going to add 1 to both sides. So y will equal negative 2x plus 7. And that would be a point that has a slope of negative 2 that does go through the point 3, 1. As a matter of fact, if I were to plug in 3 for x, I could test it. Negative 2 times 3 is negative 6, and negative 6 plus 7 does give me a y value of 1. So let's try the same thing with this point. This is a little bit more difficult because we have a slope that's a fraction, and we have a negative as part of our point. Our y value is a negative 1. So again, pause the video, see if you can work this through on your own, and then start the video and make sure that you have it correct. So I'm going to start with y minus y1 equals the slope times x minus x1. So I'm going to have y minus my y value. Y minus negative 1 is the same thing as y plus 1. That equals the slope, which is a half, times x minus 4. And so we're going to have y plus 1 equals, if I use the distributive property, 1/2 x minus 2. 1/2 times negative 4 is negative 2. And then if I subtract 1 from both sides, I'll have y equals 1/2 x minus 3. And that is my slope, or that is my equation in slope-intercept form. So let's go to what you're going to be doing for homework tonight. For your homework assignment tonight, you're going to have 15 problems altogether, but the first 5 you're just going to put in point-slope form. So they're going to give you a slope, and they're going to give you a point. And all you have to do is put it in point-slope form. So remember, point-slope form is y minus y1 equals m times x minus x1. So in this particular case, we're going to have y minus negative 1. Well, that's y plus 1. That equals your slope, which is 3, times x minus my x value. That's x minus negative 2. Well, that's x plus 2. That's what this would look like in point-slope form. That's all you're doing on the first 5 questions. That's point-slope form. Well, the next 5 questions, you're going to start out the same way we started out the first 5 questions. They're going to give you a slope and a point. You're going to put it in point-slope form just like we did here, but then you're not going to stop there. You're going to put it in slope-intercept form. Remember, that is y equals mx plus b. So to put it into that form, we're going to continue. We're going to use the distributive property here. We're going to have y plus 1 equals 3 times x plus 6, because 3 times 2 is 6. Then if I subtract 1 from both sides, I will have y equals 3x plus 5. And that's what this equation looks like in slope-intercept form. That's what the second 5 questions will look like. Then your last 5 questions, you're going to put this equation in standard form. Remember, standard form is ax plus by equals c. In other words, the x and the y are on the same side of the equation, which means we're going to want to move this 3x to the other side of the equation. So what I'm going to do is subtract 3x from both sides. So this is gone, and I will have negative 3x plus y equals 5. And now that is in standard form. Now remember, if you put something in standard form and there's a fraction, you're going to have to get rid of that fraction by multiplying by the least common denominator. So in this case, we don't have a fraction, so my final answer would look like this. And that is how you would write that equation in standard form. So you're essentially, the last 5 questions, you're going to have 3 forms: slope-intercept, or point-slope form, slope-intercept form, and then standard form. And that's what we're going to be doing on our homework. Good luck on your homework, and we will check it when we get back to class tomorrow.